So in question number 9 we have ABCD is a trapezium in which AB parallel DC and its diagonal intersect each other at the point O, so that AO by BO equal to CO by DO. So according to this question we will prove AO by BO equal to CO by DO. So first just you write this, draw PQ through O parallel to AB and DC. So from this point O I have drawn one line parallel PQ, and this PQ is parallel to AB and DC. Now I will take two triangles from here. One triangle I will take ABD and another I will take ADC. So first I will take ABD. So write in triangle ABD. So here AB is parallel with PO. So right here AB parallel PO. If AB is parallel with PO, then I can apply here Thales theorem. So using Thales theorem, AP by PD equal to BO by DO. Give this equation number 1. And another triangle I'll take in triangle ADC. So write ADC. PO is parallel with DC. So write here PO parallel DC. If PO is parallel with DC, then here also I can apply Thales theorem. So write using Thales theorem, AP by PD, AP by PD equal to AO by CO. So AO by CO. Give this equation number 2. Now from equation number 1 and 2. From equation 1 and 2, I can write AP by PD, and here also AP by PD. So these two same ratio you don't write, only you compare this and this. So I'll write here BO by DO equal to AO by CO. Now I will check our proof. In our proof we have AO by BO equal to CO by DO. Now just you interchange this value. BO by CO. So CO I'll take here and BO I'll bring here. Means I'll write CO by DO equal to AO by BO. So CO by DO equal to AO by BO. Hence shown. Now we'll do for question number 10. In question number 10, we have the diagonals of a quadrilateral ABCD intersect each other at the point O such that AO by BO equal to CO by DO, so that ABCD is a trapezium. Now according to this question, ABCD, this is a quadrilateral, and this quadrilateral I will prove this ABCD is a trapezium, and to prove this ABCD is a trapezium I have to prove AB is parallel with DC. So first I have written draw PO parallel to AB, means PO line is parallel to this AB, and to prove ABCD is a trapezium. Now in triangle ABD, means ABD, PO is parallel with AB, so I can apply here Thales theorem. So using Thales theorem, if I'll use this Thales theorem, then I can write AP by PD. So AP by PD equal to BO by DO. BO by DO. Give this equation number 1. And in our question given AO by BO. So AO by BO equal to CO by DO. This is given in our question. Now this I will arrange. See here now AP by PD equal to BO by DO. So here not matching ratio, not matching. So I will arrange from this now AO by CO. CO I'll bring here and BO I'll take here. I'll interchange, or I can do cross multiply also. BO by DO. Now AO by CO equal to BO by DO. Just I have interchanged these two. Now you compare with equation number 1. Here also we have BO by DO and here also BO by DO. So give this equation number 2. Now from equation number 1 and 2. From equation 1 and 2. So this same ratio you don't write, just these two you compare. AP by PD equal to AO by CO. AP by PD equal to AO by CO. Now if these two ratio of this triangle equal with each other, then I can write PO is parallel with DC. So therefore PO parallel with DC. This is converse of Thales theorem. And if PO is parallel with DC, then I can write PO is also parallel with AB, or I'll write directly show PO parallel with AB, or PO is parallel with CD also I can write here. So from here I can write therefore AB parallel with CD. If AB parallel with CD, then ABCD is a trapezium. So ABCD is a trapezium. So ABCD is a trapezium, hence shown.